Is it possible to build a computer into a workbench that looks like an engine? Yeah, those are intake ducts. Unsurprisingly, cutting a hole in a pegboard to mount a screen wasn't that difficult, but the number of custom parts required to put a computer below it, that's a different story. Actually, that's this story. Previously I mentioned that gaming gear likes to use elements of high-performance cars in its design, whether that's rear vents that look like the back of a sports car, or a chair like a racing seat. Since my feed is full of computers and cars, why not draw inspiration myself from both? Get creative with the air intake, like the motherboard in the middle. And with the components either side, we have a symmetrical layout with 3 fans either side. Air being drawn from under the workbench through some ducted pipes may just work. So I got to work, designing the custom frame and mounts to hold all the computer parts in place. With the bare minimum of wires plugged in, I could see the vision coming to life. Okay, that's gonna look mad. But it didn't look like my 3D model yet, and I knew with a bit more effort, it could.
I have very much bitten off more than I can chew.
For this project to be successful, there are 2 hurdles that sound simple, but I don't know how to do yet. And that is 1, hide all the cables. It needs to look good. Number 2, get the air where it needs to go. It needs to function good. In regards to air, I've already sorted out intake ducts for the processor's radiator, but I haven't made anything yet for the graphics card and its fans.
Dropping jack.
I just realized that because I've done this in like 2 segments, I can just model and print a piece that's like perfectly round that goes into the graphics card. I can pose up the second piece to kind of have like a flat edge on one side that goes right up against the motherboard. Okay, we're in business. I couldn't buy this part on the shelf with a cutout for the supports and the motherboard, but here I've got the exact piece that I need. The ideas from my head into the real world. Now you may have the software at home, but you don't need all of the hardware to create these parts, because today's sponsor PCBWay.com can help you. Simply select what you need done, upload your file, verify it is what you want made, then simply select the material you want, the color you want, and the quality you want for an instant quote to be manufactured and shipped to you. On top of a custom PCB, you can get parts CNC'd as well as other advanced manufacturing methods. Big thank you to PCBWay for sponsoring today's video. So it's 10 p.m. at night. I'm hoping this Google will help me. Core flute. There is black. Can I just get like a sheet? I just need a big sheet of this. Kangaroo flat. In stock, $8. Okay, I need to go to bed, and then tomorrow I'm going to aisle 9, bay 7.
Ear scratches and parts.
This took so long to get that like gap even. Once the black piece goes there, you won't see through. But it goes all the way across down the back there and has a little cutout for the motherboard. And now this piece needs to go under the power supply next to that. Mate, at this stage, I couldn't stop smiling. This just looked incredible. The pipes for the ducting are really close to one another, so not only do the cables need to fit between them, they also need to be sandwiched between the top layer and bottom layer of core flute, so we don't see them. It's gonna break me, man. This stuff's gonna break me. Everything is so close and tight. I think it may be possible if this freaking AIO duct stopped getting in the way. Yes, it will fit. I've got a glimmer of hope. So the power supply cables run down and then in between the 2 ducts, and they have to be like stacked very thin to fit to go through under the radiator and then into the motherboard underneath it all. My wife Chelsea came in just before. She was like, "You probably should have made this a multi-part series type project." And I was like,
Yeah, I'm thinking that now. But at least I figured out a workflow for the ducting.
See, the core flute board has these ribs between the two faces. Easy to cut along, hard to cut across, which makes cutting in a circle a nightmare. To hide the imperfections of my hand-cut parts, I designed these collar-like pieces for around the duct. To figure out where exactly to cut, I traced where the duct sat on the base layer of core flute under the workbench. Unmounted, I can then align my traced edges to mark the inner edge of the circle. This made it really easy to mark where my collar would go to hide the cuts for the clean edge. I can then trace the holes to cut onto the top layer of core flute for the ducts to pass through. I just cut out these pieces for the new PC build, and I just went to put it in. I realized, wait, these little bits didn't align because I forgot to offset this part here by 20 mil. 12:24 a.m. I've been doing like 10-hour days all week, working as hard as I could to get this build done, but yeah, it's kicking my butt. It's gonna look so good when it's done, but it's just like there's so many just little things, bro, that just keep compounding.
Just if I can get a quote on some polycarbonate, 12 mil thick sheet, clear, yes please. Awesome, thank you. Okay, local supplier, CV Plastics, $144.91 for polycarbonate. I'm hoping this goes straight in. It fits!
I can picture it now. See-through top, PC with the intakes coming in. It's gonna look insanely good.
Can you move out of the way, Eddie? Hop in your bed, Bruce. In your bed. Good boy.
At the end of the day, I want my workbench to still look a bit like a workbench. You'd remember from part 1 that Prusa sent me their Galaxy Black filament, which has a little bit of glitter. I find that sheen matches the metal better than plain black.
Oh, that went in. Wait, what the heck? So that won't work.
It turns out I made a typo entering my dimensions into the 3D modeling software, but I actually found it really fun recreating the original mounting method for my own bracket. I just love that I could retain the original look of the workbench, at least from the front.
Oh no, I've just scratched the whole thing up. This is the good side. So this one's got perfect fitment, but there's scratches all over the front from the jigsaw. I didn't really think about that. The time for taping this and using the jigsaw probably the same, just doing it by hand, even though it's annoying. It was a good idea in my head, like most of the stuff here. I'll take like one of these now, put it up through the middle. Ready? Yes, that works.
At this stage, I'm feeling cautiously optimistic because whilst the CPU's radiator fit first try, the graphics card on the other side has obstacles. For the final fan on the graphics card, the motherboard's corner has to be like kind of slid up and then like over the top for it to come up. Then I can put this on top once it's through, and that's bang on. There are literally blood, sweat and tears going into this project. Cut my finger before on the blade. I didn't fully cry, but I had my MTB sitting on the ground at the end of part 1, so we're getting there. You want a power supply? There's nothing else for you in here, bro. At the start of the video, I said there were 2 main hurdles. Hide the cables and get the air to where it needs to go. And we are smashing it until I decided to add walls inside the workbench. I bought 5mm core flute for the top and base layers, but for the walls, I bought 3mm, thinking that 3mm would clash less. But what I realized is a lot of the brackets I made in part 1 were overlapping with where I wanted the 3mm thick core flute to go.
Yeah, that's all I need.
The reason I'm telling you all this is because I want you to learn from my mistakes. So in the future, I would put my walls in the 3D model so I could see that there would be all these collisions and clashes. But at the same time, I like thinking on my feet. I printed my own washer and bolt cap for the power supply cable cover. So now it just looks like this minimal, sleek, I don't even know what. Not a power supply, I can tell you that much.
This is just looking so good, man. Oh, sheesh. That is clean. What, my hands cut to that like precision? Bro, I need to sell all the laser machines, eh? All the laser cutters. Which I just realized as well, I Googled, I think this stuff is safe to cut in a laser. I thought it wasn't. There's a lot of plastic that you can't cut in laser machines because it creates like toxic fumes. But I'm already so deep now, I've just been using my hands, so we're going. I feel a lot more proud of how like just well all those lines line up. It's really taking shape.
My relationship with time isn't great. Like, I got so frustrated in this project due to time. I greatly underestimated how long it would take to make each part and just how many custom parts I would need to make. When my wife Chelsea suggested breaking the PC building portion of this project into parts, I began to really enjoy this process again. I often forget that sometimes just taking a step back is the best way forward. Plus, it allowed me to realize that these custom fan exhaust covers, which I initially dismissed, were also the perfect way to hide the cut lines on the core flute at the back.
You want over here.
And of course, I'll always learn a lesson along the way to take on to the next project. For this part, it's you can't cut core flute too close to the edge.
Right, so it looks like I've absolutely minced this by going like way too high. Alright, let's just see what this looks like.
Thankfully, with some tweezers, I was able to salvage the piece. I think overall, I just need to remind myself to double, then triple my time estimates.
I was like, man, where the heck are the fans? I was looking in this bit, down the back. They're all covered, so I can't see easily. Oh, this is so much better. I can see on the other side now.
Yeah, remember I'm using one of ASUS's BTF edition motherboards, so all the ports are underneath. On a normal PC case, this actually makes cable management easier, plus you just don't see the cables.
Yes! That's one.
But for me, it's actually an achievement if I can get something to plug into a port.
Yes! It's in!
Alright mate, I come up with the best idea to secure the base piece of core flute up underneath the workbench. Now excuse the mess because I've run out of like workbench space because I'm using my workbench. I made this, which is a T-nut with like a bolt shaft plus a big wide head of a bolt. So if I drill a hole in the core flute, I can push this through it, and for the part sticking out, it goes down into the channel, I can twist it, and now it's locked in place. And when I say that it's locked in place, check out this. This is a piece of V-slot, one clip. It's being held, the entire base. I can't believe how easy this is. So originally I drilled a bunch of holes and then tried to line them with sliding T-nuts, but now I just have a bunch of plastic clips I can just push through, twist in place, which will also make servicing a lot easier if I ever have to remove this base panel. That is looking good.
Like this bit is saggy. Even if I like was to bolt underneath, it kind of like just lifts it but leaves like a bit of a gap.
But if I put in this area support, then it pushes them in, so like it forces them to kind of sit in place. I realized I can just 3D print the twist-in T-nut mount onto my 3D printed parts. So I can just twist this in place. And it's surprisingly strong. And with 3 of these brackets, I can independently adjust the amount of sag caused by each of the GPU duct intakes. In hindsight, I would have used a more rigid material for this base layer. But being able to solve this problem, even if it's one that I've created, feels really good. And that's why I put everything I wish I knew before I started 3D printing into my first guide. So you can begin to learn to use the tool to get the ideas from your head into the real world. I've put tips from my past videos and more in one place. So I invite you, before you try 3D printing, to click the link in the description below.
That's sick. How good.
Since you can't see the filters, I went fast and loose with the install, but since the graphics card holes are smaller, the filters would clash. What I'm hoping is that if I overlap the outer edge filters over the center one, it'll be held in place without the holes being covered.
It is. It's held in place by its neighbors. That's cool.
Between you and me, I may have forgotten to order a filter for the power supply, so we'll just pretend that that's also good to go. Unfortunately, I didn't need to use any duct tape on my ducted PC build. Also, that's what it's called. It's not the animal that goes quack, it's duct tape. And that's simply because the ducts being pushed against the parts had a good enough seal to keep good temps. Now, I did put some core flute on the back of the workbench. This will force hot air from out the rear exhaust up the wall, opposed to being able to go down and back in through the base of the workbench, or else you'll get a cycle of hot air just get hotter and hotter. And there's no point putting all these high performance computer components inside if it gets too hot that they start to thermal throttle and not perform, well, high performance. So how'd the tests go? My CPU, the AMD Ryzen 9900 X3D, peaked at 71.4 degrees, and at the same time, the GPU Asus Astro RTX 5090 peaked at 68.3 degrees. And that 5090 was sucking 651.1 watts from the wall, which is I guess to be expected, but just crazy to think. The Gen 5 NVMe SSD from Team Group hit 72 degrees max. That's a 12.3 gigabytes per second read and 11.3 gigabytes per second write. I still can't really comprehend those speeds, like 12.3 gigabytes per second. So all that's good news, yeah? The ambient temperature in here is 24 degrees, so with that air going in through the filters, so if I'm like sanding anything, doesn't matter if the dust spills over into this area, goes out the exhaust, out the back. I can feel air blowing up the back wall here and then up into the rest of the room. It works. Excluding the hand-cut core flute, this is every custom piece. Every 3D printed part required at least one iteration for perfect fitment. Many required a complete redesign from being moved too close to one another. Whilst I greatly underestimated the time required to hide cables and the hand-cut edges, I've learnt so much persevering with this project to create the idea that was in my head.
You know, like the slight realization is right now? I made it. Like it exists now. Whoa. I actually need to take a seat for a sec. I'm really proud of the effort I put in. I didn't expect it to be as hard as it was. I've never seen anything like it. My 6-cylinder engine PC build. Shout out to the sponsors, man. Asus, Team Group, MakerStore, Prusa,
and PCBWay today. I can't do it without them supplying the stuff and financing these projects, and I can't do it without you subscribing and watching, so thank you, especially for the comments of support. It helps. But it doesn't stop here, because you may have noticed in the past few videos there's a machine in the background that still has its protective film on it. And I'm hoping I can learn how to use that to add more stuff into the metal parts of this workbench. This build is going to be insane. All right, thank you for watching. And that's my afternoon break reminder, because I forget to stop. Back to building. I've never seen anything so clear in my life. It's like a fish tank for my computer. Damn.